Hi students. Today we'll see the graphical method to solve the problem. So this is a problem where maximize z is objective function, z is equal to 8x1 plus 6x2, and that subjected to the constant equation. So these are the three constant equation. First is 7x1 plus 5x2 less than equal to 35, then 3x1 plus 4x2 less than equal to 24, and 2x1 plus 6x2 less than 18, and x1 x2 greater than equal to 0, that is a non-negative constant. So how to solve by the graphical method? We have to find out the values of x1 and x2. So how to solve this we will see. So first step is to express a problem in a standard format. So first step, express in standard format. So what is the standard format? So in the standard format we have to remove this inequality sign. So this less than or equal to sign we have to remove, and we have to write the equation in standard format. So standard format, z objective function is 8x1 plus 6x2, and this is subjected to 7x1 plus 5x2 is equal to 35. Then similarly second equation, that is 3x1 plus 4x2 is equal to 24, and third equation 2x1 plus 6x2 is equal to 18. So we have removed that less than or equal to sign. There may be the less than sign or there may be the greater than sign. We have to remove that sign and equate with the right hand side. So this is a standard format. Now one by one we have to solve this equation. All the equation we have to solve and find out the coordinates on x-axis and on the y-axis. So how to solve that? So first equation I am solving here, 7x1 plus 5x2 is equal to 35. So in this case I am using first x1 is equal to 0, and I will find out what is the value of x2. So I am putting x1 is equal to 0 in this equation. You can take any value, no problem. So here I am taking the 0 for x1. So here this equation becomes 7 into 0 plus 5x2 is equal to 35. So this equation become 5x2 is equal to 35, or you will get x2 is equal to 7, because 35 divided by 5, that is 7. So when you put the x1 is equal to 0, that time you will get the value 7. Similarly, I am putting now x2 is equal to 0 in the same equation. We require the two coordinates. So suppose this is x-axis and y-axis. So here 0 and 7. So here one point we got, but we want another point on this axis, x-axis. So here we have to, for finding out this point, we are again putting x2 is equal to 0. Now in the same equation, now equation becomes 7x1 plus 5 into 0 is equal to 35, or you will get x1 is equal to 35 by 7, or you will get x1 is equal to 5. So another coordinate you will get, sorry, x1 is 5, so that is on x-axis, so 5, and x2 is 0, so that is y-axis 0. So this is first coordinate 0 7, this is second coordinate 5 0. Now again I will show in on the graph. So here you got 0 7, so 0 on x-axis, 7 on y-axis. Similarly 5 on x-axis here and 0 on y-axis. So you got these 2 points. Now you have to join this point. I will solve in the next slide. Here I will draw the graph. So similarly you have to find out the graph points for the each equation. So here we have found out for the equation number 1. Similarly I will solve for equation number 2. So equation number 2 is our 3x1 plus 4x2 is equal to 24. Now here when I am putting x1 is equal to 0, so here x1 is equal to 0, that time x2 you will get x2 is equal to 25 by 4, that is you will get a 6. So here you get coordinate 0 6, and when you will put x2 is equal to 0, that time here we are putting 0 here, that time 3, here 25 by 3, that is 8. So x1 is equal to 8. So here this coordinate you get x1 is 8, so that is on x-axis, so 8 and 0, this is another coordinate. And similarly for equation number 3, so equation number 3 is 2x1 plus 6x2 is equal to 18. So when here x1 putting is equal to 0, that time you will get x2 is equal to 18 by 6. So here we will get a 3. Here coordinates you will get 0 3, and when x2 you put the 0, that time you will get x1 is equal to 18 by 2, that is 9. So another coordinate you will get x1 is 9, so you will write first 9 and then 0. So here you got these coordinates. So I will write these coordinates first in the while drawing the graph. So for first equation you will get the coordinate, that is 0 7, that is first, and another is a 5 0. For second equation you got the coordinate 0 6 and 8 0, and for third equation you got the 0 3 and 9 0. Now you have to put this on a graph paper. So here on x-axis, so here on x-axis you are taking the x1 and on the y-axis you are taking the x2. So first coordinate is 0 7. Now I will use another color. Here I will use this color 0 7. That is the first coordinate. So 0, here it starts from 0 and 7. So here you got this 7. So this is first coordinate of a first equation, and second is a 5 0, means 5 on x-axis. So here you got the 5 and 0 here. So you got these 2 points. Now you have to join these 2 points. So here I will join these 2 points by the line. Okay, so this is joined by the line 2 points, and this is your equation number 1. Okay, so equation number 1, you know that is 7x1 plus 5x2 is less than equal to 35. So this is line for a first equation. Similarly for the second equation, so for the second equation you will get the 0 6. So here first point is 0, another point is 6. So here you get this point 0 6, and 8 0 8 on x-axis here and y 0. So here you got another point. Now again you have to join these 2 points and draw the line. So I have joined these 2 points and draw the line. So this is your second line equation. So that equation line is 3x1 plus 4x2 is less than equal to 24. Similarly for a third line, so third line 0 3. So here 0 and 3 on y-axis, 0 3, this is the first point, and 9 0. So 9 here on x-axis and 0, and you can draw the line, that is line for equation number 3. So here you can join this. So this is for equation number 3. So that equation number 3 is 2x1 plus 6x2 is less than equal to 80. Now you have to draw this line. Now the important part is, so here where is the feasible region? I will zoom this. Where is the feasible region of this equation? So how to get the answer feasible region? So when there is a less than equal to sign, so here less than equal to sign for this equation, as well as less than equal to for second, and for third less than equal to sign is there. When there is a less than equal to symbol, then feasible region is towards the origin. Towards the origin, remember this part, towards the origin means what? Below the line means towards this 0. Okay, so feasible region is towards this origin. And when there is a symbol greater than equal to, in some question it may be symbol greater than equal to, that time the feasible region is away from the origin, away from origin, or above the line, we can say, or above the line. Now in this case we are having this less than symbol for all three equation. So feasible region must be the below the line. We will check one by one. So for equation number 1 is a less than symbol. So this is a red line is a for equation number 1. So feasible region is towards the origin means, or below the line means feasible region, or we are getting the answer below this line. So what is meaning of that? Less than equal to, we are getting the answer below that line. Similarly equation number 2, again there is a less than equal to sign. So again for this equation, so this is uh, black color line. So again here feasible regions is below the line, or we can say towards the origin or towards the 0. And third equation, here again it is a less than equal symbol. So for that also the feasible region is a below the line. Okay, so below the line or towards the origin. So our answer lies below the line or towards the origin. So the minimum common region which is covered by all the lines. So here this is a minimum common feasible region which is covered by the all the lines. So we can shade out this line, this area. So this area is a common feasible region which is covered by all the line. Means equation number 3 line here is here, and below that this element area is there which is covered by all the lines. So this is feasible region. So here we will take a points of that feasible region. So where are the points of feasible region? So this is the first point, I will give a name A. This is another point, that is a name B. I will give name here, it is a C, and another name here, this coordinate is D. So we got these 4 points and we have to take the coordinate of this point. So first A coordinate, so A point, the coordinates are on x-axis it is 0, on y-axis it is 3. For B it is a point 0 0. For C this is a 5 on x-axis and 0 on y-axis. And for D, so here if you take for D, so it is around coming 3.7, and if you take on this y-axis it will coming around 2.8. So I will take on x-axis it is 3.8 and on y-axis it is a 2.8. If you draw on the graph paper, you will get the exact point. So here approximately I have taken that this is a 3.8 and 1 3.8, sorry, and not 2.8, 1.8 is here, yeah, below the 2 now. So it is a 1.8. Okay, so now you are having a objective equation. There is another color here. Okay, z objective equation, you are having 8x1 plus 6x2. Now you have to put this value is x1 value and this value is x2 value in this equation. You will get 8 into 0 plus 6 into 3, so you will get a z answer is 18. Similarly, when you are putting, so this is ZA, when you are putting the coordinates of point B, you will get 8 into 0 plus 6 into 0, you will get a 0. For C, ZC, 8 into 5 plus 6 into 0, you will get an answer 40. And for last, ZD, you will get 8 into 3.8 plus 6 into 1.8. So if you solve this answer, so you will get around, so here 8 into 3.8, you if you solve this, I will solve that. 8 into 3.8, so 8 into 3.8, that will be 30.4, 30.4 plus 6 into 1.8, you will get 10.8. So here 10.8, so you will get answer 10.8 plus 30.4. So if you check this answer, you will get a 41.2. So 41.2, that is answer for ZG. Now you got the answer 18, 0, 40 and 41.2. Now our objective equation is a Z max. So which one is a maximum value? 18, 0, 40 and 41.2. So from these all the values, 41.2 is a maximum value. So here Z max is equal to 41.2. Z max is equal to 41.2 and x1 value is 3.8 and x2 value is 1.8. So this is your final answer by the graphical method. Okay, thank you.